This research introduces a novel machine learning-based approach to assigning software issues to team members, focusing on 4 distinct roles: designer, developer, tester, and leader. The study compares the performance of shallow and ensemble methods with deep language models, incorporating the level of experience of developers to reflect industrial practices. 5 industrial data sets from a global television producer were collected and annotated, comprising 5,324 issues. The results show that the ensemble classifier of shallow techniques achieves an accuracy of 0.92 for issue assignment, comparable to state-of-the-art deep language models. The key contributions of this research include the public sharing of annotated datasets, a clear feature set, and a novel label set. Furthermore, the study validates the effectiveness of shallow machine learning techniques for issue assignment, providing a promising alternative to deep language models. This approach has significant implications for software development teams, enabling more accurate and efficient issue assignment and allocation of resources. By leveraging machine learning methods, teams can optimize their workflow and improve overall productivity. The paper emphasizes the significance of efficient issue management in software development projects, highlighting the role of issue tracking systems, in identifying, reporting, and prioritizing software issues. It introduces a novel approach to issue classification, treating it as a text classification challenge to assign issues to appropriate team members or departments. This approach leverages machine learning algorithms and natural language processing techniques to analyze and classify issue descriptions. The aim is to provide a more comprehensive and effective solution for issue management and resolution, ensuring that issues are addressed by the right people and improving overall efficiency and effectiveness. The study categorizes main teams within a software development company into software developers, UI/UX designers, software testers, and team leaders. It further subcategorizes software developers based on experience and skill sets into senior, mid, and junior levels. This categorization enhances time management and issue resolution by allocating appropriate tasks to each team member. The analysis uses a closed-source dataset from 5 projects obtained through the company's Jira interface, focusing on the main language of the issues. The study leverages natural language processing techniques, employing part-of-speech tagging and sentiment analysis to create a simpler and more successful feature set compared to traditional word embedding methods. The annotated dataset is evaluated using various machine learning, ensemble learning, and deep learning techniques, assessing the efficiency through metrics such as accuracy, precision, recall, and F1 score. Significant contributions include a publicly available closed-source issue dataset in Turkish and English, an understandable feature set, and novel labels for issue assignment, expanding current research and offering new perspectives on team categorization and task allocation. This research paper presents a roadmap for the remaining sections, which will explore the background, experimental setup, results, threats to validity, related work, and conclusions. The background section is crucial for understanding the approach, and it begins by examining software issues within issue tracking systems. These systems are software applications that manage and maintain lists of issues, providing a database of issue reports for a software project. They facilitate collaboration and alignment among team members, enabling users to log in, post new issue reports, and comment on existing ones. Popular issue tracking tools, such as Jira, Bugzilla, and Azure DevOps, share a similar basic structure. The approach developed in this paper is based on a dataset from a company using Jira software. An issue report in an issue tracking system consists of various fields, each holding different information, as illustrated in Figure 1. The generic process of reporting an issue typically includes details such as summary, description, project, component, version, priority, assignee, and tags. Understanding the anatomy of an issue is essential for comprehending the underlying themes in software development projects. This knowledge will contribute to a more comprehensive understanding of the domain, providing unique insights into the structure of software issues in issue tracking systems. In issue tracking systems, such as Jira, extracting numerical features from issue summaries and descriptions is crucial for effective issue categorization and management. Key issue attributes, including version, component, priority, severity, and status, provide essential context for understanding the issue. Attachments, which can be added to issues, offer supplementary information, while user interactions, such as reporting and assignment, provide additional insights. Revision history and estimated time spent on the issue also play a vital role in comprehending the issue's progression. These features are critical in understanding how the system processes and manages issues, enabling the identification of patterns, trends, and correlations. By leveraging these numerical features, issue tracking systems can optimize issue resolution, resource allocation, and team performance. The system's ability to categorize and manage issues efficiently is contingent upon the accurate extraction and analysis of these numerical features. This, in turn, enables data-driven decision-making, improved issue resolution rates, and enhanced team collaboration. In the context of the Jira project management tool, the workflow of issues involves a series of stages that an issue undergoes from creation to resolution. These stages comprise open, in progress, resolved, reopened, and closed. Initially, an issue is created in the open stage, where it can be assigned to an assignee. Upon assignment, the issue transitions to the in-progress stage, where the assignee begins working on it. Following resolution, the issue's subtasks are completed, and the reporter waits for verification in the resolved stage. However, if the solution requires modifications or additional details, the issue can be reopened, triggering a return to the in-progress stage. Conversely, if the issue is deemed accurate and resolved, it is marked as closed, indicating the completion of its lifecycle. A diagrammatic illustration of these stages and their possible transitions provides a visual representation of the lifecycle of an issue in Jira, highlighting the dynamic workflow of issue management within the tool. This study's methodology begins with data collection from 5 industrial projects documented on Jira software, encompassing hotel TV systems, advertising, and promotional display systems. These projects are undertaken by a leading television manufacturer specializing in B2B display solutions. Table 1 provides a summary of the datasets, including IP Hotel TV, RF Hotel TV, Hospital TV, VSYNC, and HTML Hotel TV. Each project has a distinct mission and scope, such as the IP Hotel TV being a browser-based interactive hospitality application and the Hospital TV being a hospital-specific version of the same application. The data is then pre-processed, features are extracted, and classification is performed using algorithms and models to classify the issues based on their assigned labels. The authors delve into various projects related to information systems in hospitals and hospitality industries, including RF Hotel TV, IP Hotel TV, HTML Hotel TV, and VSYNC. These projects were developed using different programming languages, such as Python, C, JavaScript, and frameworks like Django, Angular, .NET, and .NET Core. Between 2011 and 2021, these projects reported a total of 5,324 issues, ranging from 126 to 2,004 issues per project. The dataset consists of issue reports submitted by users with diverse roles, including software developers, team leaders, testers, and customer support teams. The issues are then assigned to workers with varying roles and experiences. The number of employees involved in the projects ranges from 7 to 35, considering the creator, reporter, and assignee columns. Figure 3 illustrates the distribution of team roles and software developers' experience. The figure shows that the majority of team members hold the role of software developers, followed by testers, leaders, and designers. Regarding experience, junior software developers are the most represented, followed by mid-level and senior developers. To preserve individual privacy, the authors removed employee names from the original data and replaced them with their corresponding roles in the development team, including software developers, UI, UX designers, test engineers, and team leaders. The analysis of issue assignment in a software development company is conducted using data extracted from their Jira platform, comprising 229 columns, with many fields left blank due to non-usage in project management. The dataset is predominantly in Turkish, with technical terms and jargon in English, and a portion of it is publicly available. The distribution of assignees reveals that team leaders receive the fewest issues, while software engineers are assigned the majority. Notably, junior-level developers are assigned the most issues, and senior-level developers the least, suggesting a potential correlation between expertise level and issue complexity. In the preprocessing step, raw data is prepared for analysis by exporting all issues from the Jira tracker system to an Excel file and cleaning up the data by eliminating rows with fully empty columns, particularly those containing empty assignee columns. This ensures that only relevant data is used in the analysis. Examples of issues from the dataset include problems with orders not sending emails, server testing requests, and video wall synchronization support, demonstrating the variety of issues handled by the software development team. This underscores the need for efficient issue assignment based on expertise and workload. This analysis sets the stage for further investigation into automating the issue assignment process, considering factors such as expertise level and current workload. The preprocessing steps for the Jira tracker system involve several key operations to ensure accurate data analysis. Missing numerical values are replaced with zeros to avoid issues during processing. The summary and description texts of each issue are combined into a single metadata field called issue text, which is then converted to lowercase for consistency. Tokenization is applied to split the text into individual words, followed by part of speech, POS, tagging using the Xeric library to identify the grammatical category of each word in the Turkish texts. Additional cleaning steps are performed when utilizing word embedding methods, including removing numeric characters, punctuation marks, and stop words from the issue texts. The NLTK library is used to identify and remove these stop words. Finally, lemmatization is applied to reduce words to their base form, retaining their essential meaning and simplifying text data analysis. These preprocessing steps are crucial for effective feature extraction and word embedding, as they help in reducing dimensionality, removing redundant information, and improving the accuracy of the analysis. The entire process is visualized in Figure 4, showcasing the sequence of steps from downloading issues from Jira to the final preprocessing stage. The authors describe the feature extraction process for vectors created from the Jira dataset, focusing on non-empty fields to narrow down the selection. The initial feature set includes columns from the issue tracking system, such as watchers, images, reopen count, and reassign count, which provide insights into issue progress and workflow. Additionally, Boolean features like reported by customer and tested versions are considered, indicating data presence in mostly empty fields. These features are aimed to be compared using two popular word embedding methods in subsequent sections. The importance of issue tracking in software development is emphasized through the use of various columns in an issue tracking system. These columns include approval type, effects versions, issue type, reporter, priority, frequency, and bug category, enabling effective categorization and prioritization of issues. Additionally, the application of NLP techniques, such as sentiment analysis and part-of-speech tagging, is discussed for extracting features from issue texts. This information is vital for understanding how issues are managed and how software development teams can enhance their processes. Classifying software issues as bug or not a bug is a crucial task in issue tracking systems. A machine learning model is developed to tackle this challenge by leveraging various features extracted from these systems. These features encompass linguistic cues, such as the presence of negative verbs, necessity verbs, and specific keywords like bug, design, icon, and logo. Additionally, the model incorporates features derived from issue tracking system columns, including the number of watchers, images attached, reopen count, reassign count, linked issues, subtasks, components affected, reported by customer, tested versions, test execution type, approval type, affected versions, issue type, reporter, priority, frequency, bug category, and labels added to the issue. To represent text as vectors, word embedding techniques are employed, specifically the pre-processed combination of title and description parts of issues. The most popular word embeddings utilized are bag of words, BO, term frequency, inverse document frequency, TF-IDF, and word2vec. The implementation details of these techniques are provided in the paper. The classification model's primary goal is to provide an accurate and comprehensive overview of the features and methodologies used, emphasizing the significance of precise issue identification and categorization in enhancing the efficiency of issue tracking and resolution processes. The application of machine learning algorithms for text classification is discussed, starting with the use of TF-IDF and BO algorithms, highlighting the unigram model's superiority in capturing text features. Various classification algorithms are then experimented with, including SVM, decision tree, random forest, logistic regression, KNN, and naive Bayes. The importance of proper tuning through grid search with cross-validation is emphasized to achieve high-accuracy models. Ensemble learning methods are also explored, showcasing the potential for combining predictions to improve results. The use of machine learning techniques to classify issues reported on GitHub is discussed, highlighting the limitations of deep learning-based text mining due to insufficient data. To overcome this, the authors propose using bidirectional language models such as DistilBERT, RoBERTa, and Electra, which are pre-trained on large datasets and can be fine-tuned for specific tasks. The importance of pre-trained word embeddings is also emphasized for improving deep learning models. A table detailing various features extracted from issue texts is presented, including the number of words in summaries and descriptions, polarity and subjectivity scores, part of speech tags, and the presence of specific keywords related to bugs, tests, documentation, design, necessity verbs, and negative verbs. The authors reference a study by Guven, 2022, that achieved the best performance in sentiment analysis using the Electra language model, chosen for its efficiency in computation and size compared to other transformer networks. The discussion concludes with the potential of these approaches to provide empirical evidence for the effectiveness of deep learning models in classifying GitHub issues when sufficient data is available. The experiments and results section of this research paper presents a comprehensive analysis of the proposed methodology's performance and effectiveness. The findings are evaluated using various metrics and techniques, comparing extracted features from different perspectives to understand their individual contributions to the classification task. A thorough statistical examination is conducted, employing appropriate statistical tests and measures to validate the significance and reliability of the findings. The experiment results for issue assignment are presented in Table 5, evaluating models on team assignment, TA, and developer assignment, DA. The stacking model, combining random forest and linear support vector classifier, achieves the highest accuracy with values of 0.92 for TA and 0.89 for DA. Other models, such as support vector machine, logistic regression, and random forest, demonstrate good performance with accuracies ranging from 0.86 to 0.88. The transformer-based models, including DistilBERT, RoBERTa, and Electra, show competitive accuracies, with RoBERTa and Electra achieving the highest scores in some cases. These results indicate that the proposed methodology is effective in improving the accuracy of issue assignment within software development projects. The superior performance of the stacking model suggests that combining different machine learning models can lead to better outcomes in this context. The competitive performance of transformer-based models highlights their potential for further exploration in similar tasks. This section provides valuable insights into the strengths and limitations of various machine learning models for issue assignment, contributing to the advancement of research in this area. The stacking algorithm for issue assignment demonstrates high precision and recall scores for the developer, tester, and designer classes under the team assignment (TA) approach. Specifically, the developer class exhibits a precision of 0.90 and recall of 0.99. In contrast, the leader class shows relatively lower precision and recall scores, indicating more challenging assignments for the algorithm. Under the developer assignment (DA) approach, the algorithm achieves high precision values for the senior and mid classes, with the mid class also exhibiting a high recall score of 0.94. Figure 5 compares the performance of the proposed feature set with popular word embedding techniques, including TF-IDF and BO, for issue assignment. The results show that the proposed feature set yields superior accuracy results, while TF-IDF and BO yield comparable results. Feature selection is crucial for improving the running time and generalization capability of a learning algorithm, as reducing the number of redundant and irrelevant features can enhance its performance. The authors emphasize the significance of feature selection in machine learning, highlighting its benefits in reducing algorithm running time, improving model interpretability, and identifying key factors influencing the target variable. They employ a simple approach to calculate coefficient statistics between each feature and the target variable, identifying the most important features and discarding redundant or irrelevant ones. The results, presented in figures 6 and 7, show that features like issue type, watchers, and summary words are highly influential, while others, such as reopen count, test execution type, and approval type, have no impact. Following this, the authors analyze the effective pos tags in Turkish, highlighting the most influential ones among all pos tags. They then retrain their models using scikit-learn select from model, selecting the top 8 features that exhibited the highest significance, as shown in Figure 5, demonstrating the superiority of their approach over word embedding methods. Optimizing feature subsets is crucial for achieving optimal performance in experiments. The refined feature subset, detailed in Figure 6, reveals the significance of each feature's coefficient value. To statistically compare classification methods, the study employs McNamar's test and the 5x2 CVT test. Notably, the 5x2 t-test is used to compare two classifiers by combining all datasets into a single dataset. This approach involves testing the null hypothesis, which assumes equivalent probabilities, against the alternative hypothesis, which suggests that the performances of the two models differ. In this context, the 5x2 CVT test is particularly useful for evaluating the significance of differences between classifiers. By combining multiple datasets, the study increases the robustness of the statistical analysis, providing more reliable insights into the comparative performance of the classification methods. The results of this analysis are critical in determining the most effective feature subset for achieving optimal outcomes in experiments. Figure 7 presents the coefficient values of each part of speech, pos, tag in Turkish, showcasing the feature set for Turkish pos tags. These coefficients demonstrate the importance of each pos tag in the classification model. Table 7 displays the results of a statistical test comparing the stacking algorithm with other classification models, including support vector machines, SVM, logistic regression, naive Bayes, multilayer, stochastic gradient descent, SGD, decision tree, random forest, k-nearest neighbors, KNN, 1 versus rest, voting soft, voting hard, random forest with boosting, bagged decision tree, extra trees, distill BERT, Roberta, and Electra. The p-values and hypotheses are provided for each model. The results indicate that the stacking algorithm significantly outperforms SVM, logistic regression, naive Bayes, SGD, decision tree, KNN, and 1 versus rest, with p-values less than 0.05, leading to the rejection of the null hypothesis. In contrast, the stacking algorithm is not significantly different from multilayer, random forest, voting soft, voting hard, RF with boosting, bagged DT, extra trees, distill BERT, Roberta, and Electra, with p-values greater than 0.05, leading to the acceptance of the null hypothesis. This analysis highlights the effectiveness of the stacking algorithm in Turkish pos tagging, demonstrating its robustness and competitiveness with other state-of-the-art models. The results provide valuable insights into the importance of each pos tag and the performance of different classification models in this task. The 5x2F test, an extension of the 5x2 CVT test, is applied to compare the performance of learning algorithms. This involves splitting the dataset into training and test sets, fitting algorithms A and B to the training split, and assessing their performance on the test split. This process is repeated 5 times with a rotation of the training and test sets, resulting in 2 performance difference measures. The mean and variance of these differences are then estimated, and the F statistic is calculated using equation 1, as proposed by Alpayden. The results of the statistical F-test analysis comparing the stacking algorithm to other classification models are presented in Table 7. The table provides p-values and corresponding hypothesis decisions for each classification model. With an alpha value of 0.05, the null hypothesis that there are no significant differences among all ensemble learning and deep learning techniques cannot be rejected. However, when comparing these techniques with machine learning methods, the majority of cases result in rejecting the null hypothesis, indicating significant performance variations. A discussion of potential threats to the reliability and generalizability of the study results is presented. This includes potential sources of bias, confounding variables, and other factors that may affect the validity of the study design, data collection, and analysis. An experiment for user evaluation within the company is described, aimed at investigating the effectiveness of the approach for issue assignment. The methodology used to gather feedback from users, such as surveys or interviews, and how the results will be analyzed or explained. This section also addresses validity threats concerning internal validity, external validity, construct validity, and conclusion validity, as outlined by Wolin et al., 54. Internal validity is ensured through careful data labeling by corporate employees and the utilization of well-established machine learning libraries, such as Python's sklearn package, to prevent implementation mistakes. sklearn and NLTK are employed for text preprocessing, while sklearn metrics are used to evaluate accuracy, precision, and recall. The Turkish Postagger library is used for part-of-speech tagging, a potential internal threat due to the complexity of the Turkish language. However, its high accuracy, with a 95% accuracy rate in 10-fold validation, mitigates this threat. To address external validity, the study utilizes a diverse dataset of 5 different applications with thousands of issues, covering a range of software languages, technologies, and time periods. Although the projects are primarily focused on web development for TV, the authors believe that their designed features are generalizable to other fields and can be replicated using different datasets. Construct validity is evaluated using the accuracy metric, supported by recall and precision metrics. The authors justify the use of binary classification for issue report assignment, as tasks in the organization can only be assigned to one employee. However, they acknowledge that this approach may not be suitable for scenarios where multiple stakeholders, such as business analysts, product owners, and software developers, may need to access the same task in different project management or software teams. Ensuring conclusion validity is crucial in establishing the credibility of a study's findings. To mitigate potential threats, the authors leveraged a dataset of real issue reports collected from a software development team over a 10-year period. Despite the low turnover rate among team leaders and testers, which may have introduced language similarity, statistical significance tests were employed to assess the consistency of accuracy values, thereby validating the hypotheses and demonstrating the effectiveness of the methods. In the user evaluation section, 2 domain experts, a senior software developer and a team leader, were interviewed to assess the application. Both participants possessed extensive experience, with the software developer having been employed for 3 years and the team leader for 10 years. Joint experiments were conducted to evaluate the outcomes. The first experiment involved discussing an issue with a differing assignee value, highlighting the significance of team manager decision-making in certain situations. The second experiment entailed assigning an idle issue to a junior software developer, which was deemed appropriate by both team members due to the low seniority requirement. Additionally, a dataset of 20 issues assigned and closed inits was provided to the senior software developer and team leader, who labeled the issues according to predetermined labels. A comparison of the tags revealed the accuracy of the model's assignments, thereby validating its performance. This user evaluation aimed to validate the model's performance and gather insights from domain experts. The results supported the model's effectiveness in assigning issues to suitable team members, taking into account factors such as experience and job scope. The authors compare the labels assigned by their best-performing model with those made by senior software developers and team leaders, using the ITS dataset. They analyze 4 combinations to understand labeling differences. In the first combination, all 4 agree on 11 labels. The second combination shows 13 labels where the best model and at least one employee agree. The third combination reveals 18 common labels where the best model agrees with at least one employee. 5 issues arise where employees disagree, with 3 resolved after discussion and 2 remaining undecided. The ITS labels are added to the combination, resolving the undecided issue. The results are presented in Table 8. Employees provide feedback on the system's usability, expressing willingness to use it with additional features like personnel information and Jira integration, considering it reliable and trustworthy. The team leader emphasizes the importance of human oversight in task assignments, especially in exceptional cases, to accelerate work and mitigate potential negative impacts on employee happiness and development. While the system reduces average task solution time, concerns arise about constantly assigning similar tasks to the same employee groups. The system is also expected to reduce planning time, particularly in situations where team planning meetings are undecided about task assignments. To improve the system, the application's values should be made editable, and a comprehensive, user-friendly interface suitable for business processes should be implemented. A review of related work on issue classification highlights the popularity of machine learning and information retrieval techniques in automated issue assignment, effort estimation, and prioritization. Deep learning algorithms have recently demonstrated promising advancements in word sequence representation and classification tasks. 7 categories of techniques are identified, including machine learning, information retrieval, auction, social network, tossing graph, fuzzy set, and operational research-based methods. The focus is on machine learning and deep learning architectures used to train issue assignment systems. Machine learning algorithms build supervised or unsupervised classifiers using historical bug reports to choose appropriate developers for new bug reports, with naive Bayes being the most widely used classifier in machine learning-based approaches. The current page discusses various machine learning approaches used in bug assignment, focusing on open-source projects like Eclipse and Mozilla. It highlights the use of term weighting techniques, such as TF-IDF, to estimate the value of terms. The page also mentions the application of ensemble learners, like stack generalization, and incremental learning methods to improve prediction accuracy. Additionally, it touches on the use of deep learning algorithms, particularly recurrent neural networks, RNN, and long short-term memory, LSTM, for bug report assignment recommendations. In the realm of software development, issue assignment is a crucial process that significantly impacts project efficiency and team collaboration. However, it has been largely overlooked in research, particularly when it comes to Turkish issue reports. This is due to the complexity of the Turkish language and the lack of a shared dataset for analysis. The Turkish language presents unique challenges due to its agglutinative nature, which means that words are formed by adding suffixes to roots, leading to long words with complex grammatical structures. This complexity makes natural language processing, NLP, techniques less effective, making it difficult for researchers to analyze and understand issue reports accurately. Moreover, the absence of a shared data set further hinders research in this area. A shared data set would allow researchers to compare their findings and develop more effective models for issue assignment. Without such a resource, each study must start from scratch, leading to redundant efforts and slower progress in the field. Despite these challenges, some studies have attempted to address the issue of assigning issues in Turkish software development teams. These studies have focused on developing NLP-based models that can analyze issue reports and assign them to the appropriate team member based on their expertise and current workload. One approach involves using machine learning algorithms to classify issues into different categories, such as bug reports, feature requests, or task assignments. Once classified, the issues can be further analyzed to identify the most suitable team member for each issue based on their expertise and workload. Another approach involves developing a data set of labeled issue reports, which can be used to train and test NLP models. This data set would include annotations indicating the type of issue and the team member to whom it should be assigned, providing valuable insights into the complexities of the Turkish language and the needs of software development teams. In conclusion, while the study of issue assignment in Turkish software development teams faces significant challenges due to the complexity of the Turkish language and the lack of a shared data set, researchers have made efforts to develop NLP-based models that can analyze and assign issues effectively. Further research is needed to overcome these challenges and improve the efficiency of issue assignment in software development teams. To enhance predictive performance, ensemble methods are employed to combine the strengths of individual models, mitigating their limitations. The effectiveness of the system is evaluated using a suite of metrics, including accuracy, precision, recall, and F1 score, which provide a comprehensive understanding of the model's performance. Furthermore, a tenfold cross-validation technique is utilized to refine predictions, ensuring that the model is robust and generalizable. A performance matrix is constructed to facilitate a thorough statistical analysis, enabling the comparison and contrast of the effectiveness of proposed strategies. This matrix provides a nuanced understanding of the strengths and weaknesses of each approach, allowing for the identification of optimal strategies. The proposed methodology has significant implications for software team modeling, with potential applications in diverse business branches. Future work involves developing a versatile tool that can be applied to various software team models, expanding the dataset to include different business branches, and conducting comprehensive evaluations through diverse studies. These efforts will further validate the approach and provide insights into its generalizability and scalability. The research on automated bug assignment using machine learning has made significant contributions to the field. Bhattacharya et al. Pioneered the use of machine learning in tossing graphs for accurate bug assignment. Feature selection is crucial, as Dash and Liu's work on feature selection for classification demonstrates. Pre-training in deep learning is also vital, as seen in Devlin et al.'s work on BERT. The comparison of machine learning and information retrieval techniques for bug triaging, as discussed by Goyal and Sardana, is another important aspect. Finally, ensemble-based machine learning, as presented by Johnson et al., offers a promising approach for automated bug assignment. The realm of software development, particularly bug assignment and triaging, has been extensively explored in numerous research papers. One such study by Tabak and Aydemir delves into the developer assignment to bugs, while K. Diaresis Oxel and Tikanerdigan's industrial case study focuses on automated classification of unstructured bilingual software bug reports. Furthermore, deep learning for bug triaging is a prominent area of research, with models like Deep Triage offering novel solutions. Automated frameworks for classifying and assigning bugs, such as BCAS, have also garnered significant attention. In addition, text analysis tools like TextBlob and Gensum have found applications in software development and bug management, demonstrating their potential in enhancing the efficiency of the development process. These studies collectively contribute to a comprehensive understanding of the complexities involved in bug management and the role of technology in streamlining this process. The authors provide a thorough examination of the current state of deep learning-based methods for image denoising, highlighting the limitations of existing approaches and proposing a novel framework to address these shortcomings. Conventional methods rely heavily on handcrafted priors, which often failed to capture the complexity of real-world images. Recent advances in deep learning have led to the development of data-driven approaches, such as convolutional neural networks, CNNs, and generative adversarial networks, GANs. However, these methods are prone to overfitting, lack interpretability, and struggle to generalize across diverse noise types. The authors propose a new paradigm, dubbed noise-to-void, which leverages the power of self-supervised learning to learn noise distributions from unpaired, noisy images. This approach eliminates the need for paired, clean noisy image datasets, making it more practical for real-world applications. The noise-to-void framework consists of two key components: a noise estimator network and a denoising network. The noise estimator network learns to predict the noise distribution from noisy images, while the denoising network utilizes this predicted noise distribution to perform image denoising. The authors employ a novel loss function, combining a reconstruction term with a regularization term to enforce noise consistency. Experimental results demonstrate the effectiveness of noise-to-void, outperforming state-of-the-art methods on various benchmark datasets. The authors also provide an in-depth analysis of the learned noise distributions, revealing insights into the underlying noise patterns. The proposed framework has significant implications for real-world applications, including medical imaging, astronomy, and surveillance. However, the authors acknowledge the limitations of their approach, including the requirement for large, diverse datasets for effective training. Future work involves exploring strategies to improve the robustness and generalizability of noise-to-void. Ensemble methods have emerged as a crucial class of algorithms in machine learning, widely adopted in classification, regression, and clustering applications due to their ability to enhance accuracy and robustness. The success of ensemble methods can be attributed to their capacity to reduce overfitting, increase model diversity, and provide a framework for combining the strengths of multiple models. The survey covers prominent ensemble methods, including bagging, boosting, random forest, and stacking, highlighting their key characteristics. For instance, bagging employs bootstrap sampling, while boosting involves iterative reweighting of instances. The authors also discuss various ensemble combination strategies, such as voting, averaging, and stacking, and their applications in different problem domains. Despite their advantages, ensemble methods have limitations, including increased computational cost and the need for careful hyperparameter tuning. Additionally, assumptions underlying ensemble methods, such as the independence of individual models and the accuracy of base learners, must be considered. Future work should focus on developing more efficient ensemble methods capable of handling large datasets and high-dimensional feature spaces. The authors draw attention to Zhou's 2012 comprehensive work on ensemble methods, which provides a detailed treatment of the theoretical foundations and algorithms of ensemble methods. This survey provides a thorough review of ensemble methods, covering their foundations, algorithms, and applications. By distilling the key concepts and ideas in ensemble methods, the authors have created a valuable resource for researchers and practitioners in the field of machine learning.